Assalamu alaikum, my dear students. I hope all of you are fine and doing well. Here we have the topic about the displacement reactions. Although we learn about a lot of chemical reactions around us, chemical reactions in which we may have the type of reaction which are called as the addition reaction. We may talk about the substitution reactions. We may have the reaction with the water. We may have the type of reactions in which there is a formation of the new types of the products. So here we have another type which is called as the displacement reaction. It is the one reaction in which the one wherein the atom or the set of atoms is displaced by another atom in a molecule. For example, here we have the two molecules in which the A and the B. So the one is going to replace the other in this type of reaction is basically called as the simple displacement reaction. So here in this picture you can see that we have a molecule which is consisting of A and B, and the third one is C. Now after the process or after the reaction we just seen that now the B is with the C and the A is just separate out. So in this picture we just see the C displaces the A and it replaces the A and takes the place of the A and forms a new product which is BC, and the new one side product is formed which is called A. So this type of reaction is basically called as the displacement reaction, in which the one just takes the place of the other in a chemical process. Now, here we will talk about the displacement reaction that has been done by the halogens. So the halogens are basically the group 7 elements, and halogens includes fluorine, bromine, chlorine and iodine. These four halogens just do the type of reaction which is called as the displacement reaction when they do react with the specific type of salts. So let's have a look on one by one these reactions. The first reaction is by the fluorine or the displacement reaction by the fluorine. Likewise, here we have the potassium chloride, it's KCl, and we have the fluorine F2. In this reaction, we just see that after the reaction, we have the product which is potassium fluoride and we have the chlorine. So the fluorine just displaces the chlorine in this process and takes the place of chlorine by producing chlorine gas as a byproduct. When we have a look on the fluorine, among all the halogens, it can displace all the halogens like chlorine, bromine, and iodine because the oxidizing power of the fluorine is higher among all the halogens. So that's why it can displace the all remaining halogens in a chemical process. After the fluorine reactions, we have the reactions by chlorine. In this process, we have the potassium bromide, which is KBr, and the chlorine. Now, chlorine is going to react with this, and after this reaction, we just see that the bromine has been displaced by the chlorine, and the new product we gain it is potassium chloride along with the production of the bromine. Now, when we talk about the fluorine and chlorine. The fluorine can displace the chlorine, but on the other hand, the chlorine cannot displace the fluorine because the oxidizing power of the fluorine is more as compared to the chlorine. Likewise, here we have the comparison between the bromine and chlorine. So the chlorine can displace the bromine, but the bromine can't displace the chlorine in a specific reaction. Likewise, if I am going to write that reaction in a reverse order, then this reaction could not take place because the oxidizing power of bromine is less as compared to the chlorine. So only the chlorine can displace the bromine, but not the bromine to the chlorine. This is the main thing that you have to keep it in mind. At the end, we have the reactions by bromine. Now, the bromine can be displaced by the chlorine, and if I just write the reaction as potassium iodide going to react with the bromine. Then this bromine can displace the iodine, like forming potassium bromide and the iodine. This reaction can be happened in the direct direction or in the forward reaction, but this reaction cannot be take place in the reverse reaction because the iodine is having less oxidizing power as compared to the bromine. So only the halogen which is having more oxidizing power or which is higher in the order, it can have the displacement reaction or by displacing the other halogens, but not when it is at lower level. At the end, we have the reaction by the iodine. If I am going to write that reaction like we have iodine and we have here the potassium fluoride, then we have iodine plus its reaction with the potassium chloride, and then we have iodine its reaction with the potassium bromide. Now, what would happen? All these three reactions could not take place. What is the reason? Because the oxidizing power of iodine is less as compared to fluorine, chlorine, and bromine. So, this reaction would not take place. And the order of oxidizing power for the halogens we have F2 more oxidizing power, Cl2 more, then bromine is more, and at the end we have iodine. So in this way, the iodine can displace all these three. The chlorine can displace only bromine and iodine, like the bromine can only displace the iodine only, but they cannot do the reactions in the reverse manner. So this was all about the displacement reactions today. I hope you guys understand. And if you have any queries, you may ask me about that in the comment section. The next topic that we will discuss it is the aqua regia. For that time, you guys keep learning and have a good day.